to 15.9, multiplying and dividing with complex number. So in this particular lecture video, let's take a look at how we can multiply complex number. Now before I do that, let me explain this thing I wrote, I times I. Whenever you run into or whenever you say I times I, what you're saying is I squared. But don't stop it. Don't stop at I squared. I squared is, well, the I can be written as square root of -1. So when I say whole thing squared, okay, square and square root will cancel out. So that just leave me with a -1. So basically, whenever you say I times I, that will always be -1. Okay, I times I is always equal to -1. Okay, you cannot say, well, Mr. Chen, what about -1, square root of -1 times square root of -1? Give me square root of +1. Well, that does not make any sense because if square root of -1 is not a real number anymore, how can you take two of them, multiply together, and call them a +1? So that's why we cannot see it that way. We have to look at this I times I as I squared, which allow me to say square and square root cancel out. My answer is simply -1. All right. That being said, what happened if we have I times I times I, which is I to the third? Well, the first two I times I already going to give me -1. So this is going to be -1 times I, which is -I. All right. So that means so far I to the first is I to the second, or I times I, is -1. Now come find out, I to the third power, or I times I, is -I. So what about I times I times I times I times I? Four of them, which is I to the fourth. I to the fourth, well, the first two I times I is I squared, which is -1, times another -1. So now they are real number now. I can multiply them to say that's a +1. Okay? So let me erase this real quick. I'm sorry. Let me erase this real quick. So now, what about I to the fifth power? Okay, what about I to the fifth power? I is equal to I. What about I to the fifth power? Well, that's I times itself 5 times. 1, 2, 3, 4, 5. First two is -1. Next two is -1. So -1 times -1 is +1 times the fifth I. 1 times I is still I. So I to the sixth power. I times I, 1, 2, 3, 4, 5, 6. You can begin to see the pattern. Two of them is -1. Two of them is -1. Another two is -1. -1 times -1 times -1 is again -1. So now I'm back to the same as being I squared, which is -1. So if I continue, that will be I to the 7, which is actually -I. Now what's interesting here is we can actually explain this geometrically. Okay, we can actually explain this geometrically. 1, 2, 3, 4. I to the second, I to the third, I to the fourth give me 4 different answers. So if I have a 4-sided shape, if I can have myself a 4-sided shape, okay, not a square, just 4-sided shape. Let's call this I to the first. This is I to the second. This is I to the third. This corner is I to the fourth. See the four corner? Okay, I'm gonna say I, -1. I'm gonna put it in the inside. Okay, I to the third is -I, and I to the fourth is 1. So when I go again, so if I go all the way around, when I go back to I, after 4 is 5. This is I to the fifth. I to the fifth, down, I to the sixth, I to the seventh, I to the 8. So I to the 8 lands on I to the 4, which is 1. That's why my I to the 8 here is equal to 1. This example here is going to be a positive 1. That's the reason why. All right. So I to the 11. This is 8 already, right? 8, 9, 10, 11. 11 actually fall on I to the 3rd, which is negative I. So that tells me I to the 11 power is negative I. That's how I know the answer so quick. Okay, because it repeats. It actually go back to the original 4. All right, so that was kind of cool. All right, find the product. So these are just, we're gonna work these problems just like we done similarly before, except now I got myself some complex number in the parenthesis. All right, square root of 6, 6 cannot be broken down, so square root of 6 stays the same. So let's distribute with my 4. So 4 times square root of 6 is 4 times square root of 6. 4 times positive 5i is positive 20i. Now, make sure you understand this. This is actually a real number because it does not have an I with it. So this is a real part, and the second term is the imaginary part. So this is my answer. The two terms are not like terms. All right, this is difference of square. A is the same. B is 7i. So 1 plus, 1 minus. So that gives me difference of square. And I purposely picked this example here. This is just like how we did the difference of square before involving with radical. Because the difference of square showed us before, that's how we get rid of the square root in other video. So this difference of square here is going to help me to cancel out my imaginary numbers. Because if I can conjugate, okay, if I perform my conjugation here, my imaginary number will go away. And we will need this concept when it comes to rationalize the denominator, again, involving with complex number in the next video. So my A is 2 whole thing squared minus my B is 7i whole thing squared. Be careful, okay? 2 squared is 4 minus, all right, if I do a power rule here, 7 squared is 49. What about the I square part? You can't just put an I square here. I square actually representing negative 1. So if I square is negative 1 and my 49 is already negative, so that will actually make my negative sign here becomes positive, okay, because the I square. 7 squared is 49, subtract this negative sign is already there, but the I square give me another negative, so the two negative multiplied together will actually make my second term positive 49. So 4 plus 49 is 53. See, the answer has no imaginary number in it. All right, let's do the FOIL method. I'm going to do this step at a time, okay? Negative 4, distribute. Okay, FOIL method. First and outer, negative 4 times square root of 5, negative 4 square root of 5. Negative 4 times positive 4i is negative 16i. All right, inner, negative 3i times square root of 5 is negative 3 square root of 5i. Or you can say negative 3i square root of 5, either way. Be very careful here. Negative 3i times positive 4i is supposed to be negative 12i squared. But the I squared part is going to be negative 1, which will make my negative 12 become positive. So I times I is I squared, which is negative 1. But my 12 was supposed to be negative. So with the extra negative times my negative 12 will make that 12 positive. All right, so this is kind of strange looking. So these first and the last term are real number. So let's rewrite my answer. I'm going to put my 12 up front, minus 4 times square root of 5. And these two terms, okay, involves with radical, and both terms has an I, so I'm going to factor out a negative I, since both terms are negative. And I like to put my I on the back, sorry guys. So If I factor a negative, so that negative 16 become positive. This negative 3 square root of 5 become positive. So I can write my answer as 12 minus 4 times square root of 5 minus parentheses 16 plus 3 times square root of 5 whole thing times I. Okay, I can write it this way, or I can just simply have 12 minus 4 times square root of 5, okay, minus 16I minus 3 times square root of 5I. Okay, this I is on the outside. So I just normally factor out the I. Okay, so different way we can write this this answer. But what the homework is trying to show us, okay, the solution trying to show us is make sure we see that this first two terms is the real part, and the last two terms are the imaginary part. Okay, so I can even do it this way. Well, you see the first two terms, I can actually factor out a 4. So that's 4 times 3 minus square root of 5. Okay, the last two terms is going to be negative 16 plus minus parentheses 16 times 3 times square root of 5I. Okay, so different way to write the same thing. Okay, that all depends on what the solution. It all depends on what the Hawks Learning want you to enter in as. Let's try another one. Okay. This is another FOIL methods. 4 times 2, 4 times positive I square root of 3, so that will give me 8. Positive 4 square root of 3I, right? 4 times positive I square root of 3, positive 4 square root of 3I. Inner, negative I square root of 5 times 2, negative 2 square root of 5I. Negative I square root of 3 times positive I square root of 3. Well, square root of 5 times square root of 3 is going to be square root of 15. Negative times a positive is supposed to be negative, but the I times I will actually give me a negative 1. So with a negative sign in front of it, negative 1, negative times negative will make the square root of 15 positive. So no like terms, right? No like terms here at all because the radicands are different. So let me rewrite my A up front, positive square root of 15. Second term, all right? These two terms involving with radical and imaginary is my imaginary part. So I will be positive 4, okay? Parenthesis, positive 4 square root of 3 minus 2 times square root of 5. And then factor out the I. All right, so just quickly talk about how we can multiply our imaginary number itself together, okay, and how we can multiply our complex number. All right, that will conclude this lecture video. Thank you for watching.